This lesson covers volume of pyramids and cones. Turn to page 9 in your packet. We're going to fill in volume formulas for pyramids and cones. So in this left-hand picture you have a cone, and you might remember from earlier calculations we have a base that's a circle with a radius of r. We have a height that goes from the vertex down to the center of the base. We also have the slant height, which is useful when we're calculating surface areas. The pyramid also has a slant height and a height. So we have the square pyramid where we have the height that goes from the vertex down to the base, and the slant height is the height of the base. So which height do we need for volume? Do you think we're going to need slant height or height? So we have a lot of choices here. So we have height of prism pyramid cylinders, the base, when you do calculations for bases. We also have the slant height, which is for lateral faces. For the cones, we need the vertical height itself, directly from the vertex down to the base. The formula for the volume of a cone. Volume equals 1/3 pi r squared h. Now you might wonder why the 1/3 is in there. The pi r squared is a circle times height, which is normally a cylinder, but 1/3 of that represents a cone. If you look at this visual over here, you can see they give an example. It says it takes 3 cones to fill one cylinder with the same radius and height as a cone. So if I take this little cone and I move it over here, it does seem to fill in about 1/3 of the size. Visually, it looks like you could fit another cone to the left of it upside down and another cone to the right of it upside down. So now we're going to do some practice using the formulas. So we find the volumes of the cones, and in this particular cone you're given a base that's a circle, so you have a radius of 3 and a height of 9. 1/3 pi times 3 squared times 9 gives me 27 pi inches cubed, or 84.82 inches cubed. Number 2 looks a little different. This time they give you the radius, but they give you the slant height. So you're going to need to draw in an altitude going from the vertex down to the base. You are creating a right angle. So you're going to use Pythagorean theorem to figure out your height. Radius is 9, and your height ultimately is going to be 33.82. Doing this problem, I'm treating the slant height as the hypotenuse, and I can put the 35 over on the other side if I'd like to. Do Pythagorean theorem. So my unknown height of h, so I'm taking 35 squared minus 9 squared, which will be 1144, and the square root is 33.82. So volume calculation, 1/3 times pi times the radius squared times the height is going to be 913.14 pi feet cubed, or 2,868.71 feet cubed. Going back to page 9 again, for you, you're going to put in the formulas for the pyramid. A pyramid works very similar to a cone. Its volume is also 1/3 base height, but this time the base is going to be whatever shape that you're given. B is the area of the base, and P is the perimeter of the base. You'll notice in this picture down here I've shown you a pyramid embedded into a prism, and it would take about 2 more to fill it up. Let's go ahead and do a practice problem. So for number 3, in this problem you'll notice the base is a little bit different. It's a rectangle because we have a length and width of 5 and 6, and that still works for volume. Volume is easier to calculate when your bases aren't regular. Your height is given as a 10, and the base being a rectangle, you're just taking 5 times 6, which is 30. So you have 1/3 base height. 1/3 times 30 times 10 is 100 centimeters cubed. Number 4 is a little bit unusual. This picture looks like you're either looking at the top of a pyramid where all of the sides of the faces meet at 90-degree angles, or you could pretend this is sitting in the corner of a room on the floor and it looks like these are triangles that are meeting together as a base, and then the sides, and then there's this large flat equilateral. Now this one, you could treat the large equilateral as the base, do a height from its center up to the top if you treated this piece here as the top. But technically it's easier to look at this a little bit differently. Notice that all of the sides, or the edges, the lateral edges, are all 4s. What that indicates is that this picture is unique. It's a third of a cube where all of the sides are 4s. I could draw a cube over the top of this, and it becomes very easy to see that it's the third of the size of a cube where all of the sides are 4. This is much easier to do a calculation than going through the same process as the other pyramids. So rather than using the traditional formula, I'm going to treat it as 1/3 of a cube. The volume of a cube is a side cubed, so it's 1/3 of 64, which is 64 centimeters cubed. This one is very tricky to notice how to do the problem because it is so much easier to do it as a cube rather than going through the same procedure. Number 5. So in this case we have a base that's a triangle, and they're giving you the height of 7.3. But what you will notice is with this particular base, you have a right triangular base, and I know the hypotenuse but not one of the legs, which I need to use to calculate the area of the base. This particular leg is going to be the square root of the hypotenuse squared minus the other leg squared. So this particular leg is 6.16. To calculate the area of the base, I'm going to take 1/2 times the 6.7 times the 6.16. And that base gives me a total of 20.74. And I am going to go ahead and use decimals since I'm already working those. And they tell you the height is 7.3 inches. So volume will be 1/3 times the base times the height, which gives me 50.21 inches cubed. Number 6, you'll notice you have a degree of 26. So we're going to be working with some trigonometric ratios. And I've added an r into the picture because I don't know the radius of my base. So in this particular problem, the trig ratio that you're going to use is tangent, because the opposite for 26, opposite over adjacent, which is r over 22. So we have that the tangent of 26 is r over 22. If we multiply both sides by 22, you get 22 tan 26. You can convert this to a decimal earlier or later. It is up to you. The height of this particular problem is 22, so the volume is going to be 1/3 pi times 22 tan 26 times 22. You're going to get approximately 22,652.47 feet cubed. This next portion includes practice problems. There are a total of 8 problems that you're going to work out, so you want to pause the video, work out the problems, and then check your answers on the video. If you struggle with these problems, come see me and I'll show you the answer key with the worked out pieces. Pause the video now. Here are the answers to each of these problems. Number 1, the answer is 20 inches cubed. Number 2, 163.49 centimeters cubed. Number 3, 100.53 centimeters cubed. Number 4, notice they're giving you the volume. You're going to have to work backwards to find that missing height. Your height is 6 inches. Number 6, you're going to have to use a trigonometric ratio. Number 6, they give you 2 parts here. 5 says find the height of x, which is 20.80, and finding the volume is 3,681.11 meters squared. Number 7, the diameter is 6.78 feet. And number 8, 1,799 inches cubed. This concludes the video for volume of pyramids and cones.